Hi, I'm Bob Tabor with LearnVisualStudio.net. In this lesson, we'll talk about a bunch of topics that surround classes and objects and methods. We'll talk more about object references and how the .NET runtime manages the memory that your objects use. We'll look a little bit more into passing objects as parameters into methods. We'll talk about constructors, which are special methods that fire each time you create a new instance of a class. And finally, we'll talk about shared methods. There's an important distinction to understand in .NET and Visual Basic when working with classes and objects. So in the previous lesson, we created this line of code, line 6, in order to create a new instance of a class. Dim my new car as new car. Now, before we just gloss over that idea and keep moving on, let's really think about what's happening here. The .NET framework has to go and create a spot in the computer's memory sufficiently large enough to hold a new instance of the car class. The computer's memory has addresses similar to the street address of your home, so the .NET framework creates a place in memory, takes note of that address, where it put that instance of the car class, and then serves that address back to you, the programmer, to use as you see fit. So the my new car is simply holding an address, a reference to the instance of the car class in the computer's memory. Whenever you need to work with that instance of the car class, then you just use the my new car identifier, and the .NET framework takes care of the rest for you. So it gives you the illusion that you're working with the object, but you're really just holding on to a reference to that object in the memory. The .NET Framework runtime cleans up memory every once in a while by counting references. So if we're no longer holding on to any references to an instance of a given class, the car class, then it will remove the data that's stored in that spot in memory. This process is known as garbage collection. So another kind of thing that you can do is this. All right, so what do you think that I just did in line number 7? Well, you now have two references to the same object in memory. It's kind of like having a handle for our bucket in the computer's memory. The handle is the address, so you hold on to the bucket using the handle. What we did in line number 7 is to attach a second handle, so now that we can use either one to hold on to the bucket, so to speak. So as the references go out of scope or are set to nothing, then the reference count goes down to 0. And at some point in the future, some indeterminate time, the .NET Runtime's garbage collector will go around and remove these objects from memory. They, in essence, empty the garbage buckets out, and the memory that was used can now be used for some other purpose. So I said all of that to just say this. When you pass an object as an input parameter to a method like we did in the previous lesson, with determine market value, we created a helper method here, and we passed buy val my car as car. You are only passing a copy of the original reference, or rather a copy of the original handle to your bucket. If you want to point that reference to a new instance of a class, you can do it temporarily within the body of the method. However, it'll make no lasting change outside of the method. You only modified the copy of the reference, not the original reference, and definitely not the original object instance in memory. So this is called passing by value. All right, and I realize that that probably made absolutely no sense. So let's create a small example to demonstrate exactly what it is that we're trying to do here. Let's create a couple more helper methods. And so I'm going to demonstrate how to pass an object by reference and how to pass an object by value. Up to this point, we've only seen the by value side. But let's see what the practical implication is of passing an object in both ways. So here's what we're going to do. All right, and then let's comment that out, and let's just kind of collect everything together here. And right here, what we're going to do is write the following. All right, so what are we doing here? We have created a small helper method called doByValue. And the purpose of this is just to illustrate what happens whenever we use this byval keyword. What are we passing into this method? Are we passing in the object itself, or rather the address to the original object, or are we making a copy of that address? Well, we'll find out soon enough, because what we're going to immediately do is create a new instance of car and set that reference, that new reference in memory to my car, and then change its make. And so now, if we were to use the original value that was passed in from here, we would see something different here in the second time that we reference it after we call doByValue. So let's run the application. And you can see before the value was Oldsmobile, we went off and tried to change the value, but because we were only working with a copy of my new car and not my new car's address itself, we're only making a change to that copy. Once this goes out of scope and our doByValue is finished, that copy is thrown away. So it's not permanently making the changes. So therefore, when we come back the second time and try to print out the make, it's still using the value of make from previously, where we set it here. Okay? Now, let's show that in contrast to a second example where we'll create a byref version of this. And all we'll do, and let me call this, we'll just change from byval to byref. Everything else will stay the same. So I'm going to copy this and paste it. And now here, what I want to do is called doByReference my new car. And then let's just copy that. And after by reference. All right, so now let's run the second example. And you can see this time it does indeed change the value of make from Oldsmobile to BMW. So what does that mean? That means when we call doByReference and we pass in the reference to my new car, that we're passing in the address itself, not a copy of an address, the actual address to that position in the computer's memory. So when we make changes to it, we're actually making changes to that place in the computer's memory, not just a copy of it. All right, so just understand that as you pass around references to your objects into other methods, that you need to be aware of what you're trying to accomplish. Are you trying to pass the value of the object, in which case a copy is made and then discarded and no permanent lasting changes are made to the original object? Or are you trying to pass by reference, in which case you're passing the actual address to the position in memory, so any changes that you make during that time will be made to that position in memory. And so when you have a second reference to it, like we have here, it will impact that. Okay, small distinction. Hopefully, if it doesn't help you now, you'll recall in mind whenever you're working with your applications why something isn't working quite right, or you'll at least understand why some methods within classes in the .NET Framework Base Class Library require you to pass in by reference or by value. All right, so let's recap what we know about classes so far. A class is simply a blueprint, and an object is an instance of that blueprint or an instance of that class. A new instance of a class is created whenever you use the new keyword, like we did right here. creating a new instance of a class using the new keyword creates a space in the memory of the computer large enough to hold that object instance. And what's returned is the address to that object in the computer's memory. You can then interact with that object in memory by using its address, which you hold on to using a variable like we've done here. And so that's what we've been calling an object reference. It's the variable that holds the address to the position in memory where that instance of that class is stored. You can pass the object reference to a method through an input parameter, as we saw in the previous lesson, but when you do, you're actually passing just a copy of the object. This is called passing by value. The practical implication of this is that the method attempts to change the object reference. It will not affect the original object reference, but rather the copy. If you need to pass the actual object reference so that the method will modify the original reference object, then you have to pass using the by-ref keyword, which is also known as passing by reference. All right. So, by the way, this actually works with simple types as well. I've created this exact same example, but just using an integer. So here we have dim I is integer equal to 0. So we print out the value of the integer I. Then we call do by value, where we attempt to add 1 to whatever the original value was, and we get that printed out to screen. But then we pass in by reference and see what happens there. So let's run the application, and as we would expect, what is sent by value is a copy of the value, not the original value. But when we pass in the value by reference, now we're able to modify the original value. All right. So, at any rate, moving on, let's talk about this line of code one more time. Notice the parentheses on the end of as new car. Recall that a set of parentheses is method invocation operator. Whether you realize it or not, you're actually calling a method whenever you create a new instance of a class. This new method is called a constructor, and it allows you, the developer, the option to write some code at the moment of instantiation, that moment when a new instance of your class has been created. Constructors can be used for any purpose, but they're typically used to put the new object into a valid state, meaning that you can then use it. Well, you can use the constructor to initialize the properties of the object. Once they're initialized, it's safe to be used by the rest of the application. So let's just create a quick example. You might want to set the properties of a car when it's created to some default state in order to get it ready to be used. So let's expand our car example here. And I'm actually going to add 2 additional properties. And then what I'm going to do is create a constructor. So as you can see, to create a constructor, all you need to do is create a public sub new, which corresponds with the new keyword that's used at the point of instantiation. All right, so that's easy to remember. Now, what happens if you don't create this constructor? What happens if we just leave it off and don't actually write this? Well, nothing actually. A default constructor, basically a public sub new like we just wrote, with no input parameters and no method body, is created automatically for you. You still, no matter what, will have a constructor, it just won't do anything. But by defining one or more constructors, we'll talk about how that's possible in just a moment, but by defining one or more constructors, you're merely taking control of the process of instantiation. Now, we've already talked about overloaded methods when previously looking at the console.writeLine method. There were actually like 17 different ways to call that method. And the reason that there's so many ways to call it is to make it flexible enough to accommodate all the different data types without having to call toString on each given data type. The flexibility makes it more useful without changing the core purpose of that method. So you can create your own overloaded versions of methods within inside your own classes, and it's really easy to do. You just keep the same method name, but you change the number or the type or the input parameters for the given method. So let's apply that first of all to constructors, and then we'll expand on that a little bit later. So let's get our constructor back by going public sub new, and then let's create a second version. And then inside the body of this new constructor, I'm going to go ahead and set the properties that were passed in. And you can even do things like look up values from a database, or in this case, I'm going to perform a simple calculation to determine the surcharge at the point of instantiation. So now when we go to create a new car, we have a second option. And you can see I have in IntelliSense now the ability to pass in the make, the year, and the amount. So that is an overloaded version of the constructor. Let's comment that out. And let's talk about some of the rules of overloading methods. And a constructor is just a special kind of method, but it has to follow these same rules as well. For example, you cannot do this. As you see, whenever I finish the second my method and I hover my mouse cursor over it, it says it has multiple definitions with identical signatures. And the identical signatures part is the important part. Regardless of the fact that we named our parameter differently, the fact that there's still just one parameter and it's of type string, and this is also a public sub, they both are, means that this is a violation. Now the following could be done instead. We could add, for example, a second parameter. We could even call it by the same name as before, and that would be fine. Or we could create a third with just one parameter. As long as the input parameter type was different, in this case integer as opposed to string. So each of these overloaded versions of the my method have either a different input parameter type or a different number of input parameters, or both. So we can combine those techniques for creating overloaded constructors, as I showed a little bit earlier. Also, many times classes that we'll work with related to building .NET applications don't require you to create a new instance of them. So you might see something like this as we've used already. Array.reverse, remember that from earlier? Datetime.now, string.format, or console.writeline. Did you ever wonder how it was that we were able to use those methods and properties without first creating an instance of their class? They just kind of pop up out of nowhere and they're instantly on and available for us to utilize them. Well, how is that possible? It's only possible because when Microsoft created them, they defined certain methods as static methods. In Visual Basic, the key word is shared. So you can create your own static methods, or rather shared methods as well. Again, our objective here is at the outset to help you utilize the .NET Framework library. So just know that some classes that you'll want to work with will require you to first create an instance of a class, and others will be available as shared members. In other words, their shared methods will be available without requiring you first to create an instance. But just so you can see how these things work, it's really simple. All you have to do is just add the Visual Basic keyword shared. So let's do that. And so suppose that we want to create a utility class called carlot. And typically I'll put this in another file called carlot.vb. But just to demonstrate the fact that you can put two classes in the same file, I'm going to just move down to the bottom of the previous car class and add a public class carlot. And inside of that, I'm going to create a shared method. And just to make this a complete example, I'm going to allow an input parameter, but we really don't need that for this example. This would work regardless of whether we do this or not. And so then the body of the method goes here. Now, the key to this is how we would use this shared method add to inventory inside of our application. So we might do something like this. Carlot. Now we don't have to create a new instance of it. We can just use the class name, and then we're going to use the period on the keyboard. And notice that add to inventory pops up because it's a shared method. We don't have to create an instance of it. And here we would pass in my new car. Now, admittedly, it's a bit more complicated to explain why or in what situations would you want to create your own shared members on your classes. That would require a longer discussion of design patterns and coding heuristics. Again, I just want to show you, or I just want you to know what they are and how you'll encounter them when working with the .NET Framework Base Class Library. And so you can pick up the rest later whenever you're designing your own code libraries. Alright, so we covered quite a bit in this lesson. I hope I didn't blow you away. These aren't vital concepts, but you will see this as you work through your applications utilizing the .NET Framework Base Class Library. So with that in mind, we're going to continue to push even further into classes, talking about inheritance in the next video. We'll see you there. Thank you.